Hello and welcome to this video about Python for data handling. We are excited to have you here, and in this video you will learn about Python's conditional code branching, the match case pattern, and logic operators. In this video we will talk some about if-then-else statements, which are fundamental to data science, data handling, and machine learning. And we will talk some about a selection of logic or Boolean logic operators. The purpose of conditional code branching is to execute different code for different events, where the code branching is to be guided by objects' values or properties using rules defined using logic operators as the rule maker. The logic operators you will learn to use are the fundamental Boolean operators and or operators and simple operators such as less than, equals, or larger than x operators. And you will learn to use if-elif-else statements with these logic operators. When combined, loops, conditional code branching, and logic operators creates a package with a lot of useful capability. So alright, now we'll talk about loops, conditional code branching, including the match case pattern, and some logic operators. Alright, now we'll talk some about conditional code branching, loops, and logic operators. Conditional code branching is within data handling about executing different code for different events or different objects. Conditional code branching can be used to divide data or to execute different code for different data. The tools we have to aid us with conditional code branching is loops to process data and logic operators to determine which branch should be used for an object or an advanced object or even parts of an object. The control structures we'll focus on is the if-elif-else statements, the match case pattern, which executes a similar control task with a simpler code and possibility of using fast compiled patterns for the possibility of a faster code execution. We will teach you some logic operators which will function as rules for evaluating and determining which execution branch an object will follow. And there is a very large family of logic operators, and all logic operators have something in common. And that is that you ask it a question with a statement, and if that statement is found to be true, the logic operator returns true. And if not, they return false. And these logical questions can be used with the conditionally branching code, for example, if-elif-else statements or match case pattern structures, and be used to divide the execution of code into different code blocks depending on if a statement or pattern match test returns true or false. This ability to use different code blocks or multiple code blocks gives us the capability to perform different actions depending on a logic condition. And now we have two main concepts, the structures for conditionally branching code and the logic operators creating the rules for choosing which branch to execute or which code block to execute or which of many code blocks to execute. So let us first take a look at the conditionally branching structures. And on the screen you can see a simple if-else-if and else structure to the left, plus a case match pattern structure to the right. In this case, the pattern could be a string or a string number, and these patterns can be used to match the string or number against strings or numbers for a number of cases or code blocks. The if-else-if-else structure is much more advanced, flexible, powerful, and possibly non-Pythonic than the case match pattern structure, whereas the match case pattern structure generally is much more Pythonic and very often a lot faster. If we look at the if-elif structure, we could send a data point through this structure and test it and modify it. For example, if the data point object value is larger than 55, execute statement A. Else if the object value is less than 25, execute statement B, and so on. The case match structure, on the other hand, can, for example, compare a string versus a set of predefined strings and execute different code for the string depending on which string case it match or don't match. And in the case of simpler structures, the case match structure can be made to be completely equivalent to the if-elif-else statement. And as you can see, these conditional code branching structures can be very useful for data handling. So let's take a look at the logic operators we will use to inter alia establish the rules that moves objects between different parts of the conditional code branching structures. So right, let's talk some about Python's logic operators. The definitions of logic operators is kind of loose despite the exact mathematics. And while all well-known definitions are united in that they consist of Boolean logic operators, some definitions define Boolean operators as first-stage operations and logic operators as a tool to combine more than one Boolean questions into a complex statement. And to make matters simple, in this video, the concept of logic operators will include both one-statement Boolean statements and multi-statement Boolean statements, all inclusive, everything included, nothing forgotten. And here on the screen we have the mentioned Python logic operators, the Boolean logic, and the logic statements. So let's begin from the bottom of the hierarchy and talk about logic statements. And Python logic statements mainly compare two Python objects and return true or false depending on the rule for comparison, the objects and the object's values. We have comparison rules, we have identity check rules, and membership check rules. A common comparison is that we want to check if one Python object's value is smaller or larger than another Python object's value, for example, two floats or integer values. And this is by far the most common type of comparison used for conditional code branching. A more unusual comparison is identity statements, which are used to check if an object A is object B, something that can be useful considering Python's sometimes nested object development with object views, sometimes creating the impression that different views of the same object are two different objects. Membership comparisons can be used to check, for example, if a specified object exists within a collection object or not. For example, if an integer object is included in a list or similar items. So right, let us now take a look at Python Boolean statements. And Python Boolean variables are variables that can take two values, either true or false. The Boolean variable is the standard return type of a Python logic statement and are created using Python's logic statements. Python Boolean logic statements are used to compare two or more Boolean variables, mainly using the AND or not operator. And on the screen we have to the left an example with three Boolean variables A, B, and C. We have some examples of Boolean logic statements derived from Boolean variables A and B. First we have A and B. This is false due to A being true and B being false, whereas A and B requires both A and B to be true. Secondly, we have A or B. This statement requires that at least one of the two booleans is to be true, and in this case A is true, and therefore A or B is true. We also have not B, which is true because B is false. So all right, to the right we have a further description on how to further modify Boolean logic statements by changing a true requirement to a false requirement. And here we show how to make the false true and vice versa, which may be useful for control logic for conditional code branching, but may also become non-Pythonic when these things becomes too complex. So let's continue and take a practical look at how to use logic statements, Boolean logic, and logic operators to control the flow of conditional code branching structures. And here we have some good Pythonic examples of logic statements useful to control conditional code branching. First we have A is less than B and A is less than or equals B. These less than or greater than statements are very useful to handle numeric variables. We also have the equal statement, which checks both the type and value of the two compared variables. And finally, we have a not equal statement, which also checks both the type and value of the two variables. And to the right, we give you a few pointers on what is Pythonic when it comes to control logic for conditional code branching. And logic operators using Boolean logic should be implemented as simple and Pythonic as possible. Logic statements should not be more than two and preferably only one. Complex not equal statements or combinations of statements may very quickly become non-Pythonic. A not equals A or B may become very hard to visualize as compared to A, at least one of them or both true statement. A good rule of the thumb is that a not equal statement should compare against a single value object or a single existence question, such as not in a list or collection, because otherwise just understanding the statement may require a pen and paper and hours of drawing the logic and studying the problem. And we don't want to create problems or talk about problems. So all right, let's take a look at the if-elif-else structures. And here we have the most common programming structure for conditionally branching code. And this piece of code is used to execute different code for different outcomes of the logic statements created by the if, else-if, and else statements in the structure. So here we can see that depending on what is true and false in the structure, for this example, one of the code pieces X, Y, or Z will be executed. One thing of importance with these logic tests is that tests are not necessarily mutually exclusive of each other. And this means that the tests may overlap each other or even leave gaps in the logic. Such gaps is generally captured by the else statement. And for a data handling example, this means that a data point may logically belong to many of the tests or to none of the tests, or the else capture all option. The code execution is, however, mutually exclusive for every branch, and the structure will for every pass only select one branch to execute. If the logic has overlaps or a data point belongs to many statements, Python will select the first true branch as the execution branch for the data point. So right, before we start coding, we will take a look at stepwise and chain comparisons and a colored code example. And on the screen, you can see an example showing chain comparisons and some code also showing a simple chain comparison in the else-if statement. And at the top of the text on the screen, there is a chain theory example and a simple theoretic stepwise comparison example. And these show Pythonic ways to implement stepwise and chain logic tests from the tools we have learned so far. So, here we can see how to use conditional code branching with the if-elif-else statements to create tools to modify data using logic and Boolean statements. And first we have the chain comparison, and directly after the stepwise comparisons where we, if A is true for data point x1, do some code. If B is true for data point x1, do some code. And as you can see, there are different ways to control the execution of code for different data values. And the colored code example is an example of how to turn data values to string labels in raw Python. Here we have made sure that the logic is mutually exclusive, but this could easily be changed. In the else-if statement, we have a chain comparison of the same type as in the example. And this looks simple, doesn't it? So, if you want to change this statement to a stepwise comparison with a similar result, the else-if could be changed to an if, and the else could be changed to an if list one item is less than 5,000, execute the code list two append low. And as long as the logic is mutually exclusive, the result will be similar. And if the logic is not mutually exclusive, you might either create a gap in the logic, or you might execute multiple code blocks with a stepwise example. So, all right, now it is time to type some code, so start up your code editors. All right, having started our code editors, we will start by creating a list of integers which we will use to show conditional code branching and some Python logic operators. First, we type some information about what this code is about. So we type Python conditional code branching and logic operators. And now we'll create a list of integers and modify the values in the list. So we type create a list of integers and modify the integers. And we begin list1 equals 2, 2, 4, 4, 6, 6, 8, 8, 10, 10, 12, 12. This is simple and nothing fancy. And we type for item in range of the length of list 1 list 1 item equals list 1 item times 1000, and we will print list 1. So let's run this code. And here we have the list of integers which we will use for this video. So let's now use conditional code branching for a standard data handling task. We begin to create a list 2, and we make it an empty list. And this list will store recoded results. And we type for item in list 1, if item is larger than 7,000, list 2, append high. Else if item is less than or equals 7,000 and item is larger than 5,000, list 2, append medium. Else list 2, append low. And here we can see that we have conditional code branching and that we have a bit more complex else if statement. So let's run this code. And here we can say that we use Python's fast read-only for loop and use another list to store the results of the recoding operation. And in many types of tasks, but not every task, this creates speed at the expense of memory. And this example shows the entire if-elif-else conditional code branching and utilizes the else catch-all option. And now we will print the results as a table using another for loop. And in this case, you can note that the lists have the same lengths. We type for item in range of the length of list 2, print string list 2 item plus \tab plus string list 2 item. So let's run this code. And here we can see our abstract table of data and recoded data. And we can remake the same code, but with the range length for loop. So we can say that we have the similar effect, but with the range length for loop. And we can create a list tree. And we type for item in range of the length of list 1 if list 1 item is larger than 7,000, list 3 append high. Else if list 1 item is less than or equals 7,000 and list 1 item is larger than or equals 5,000, list 3 append medium. Else list 3 append low. And we can print the result into a table using another for loop. And once again, note that the lists have the same length. We can simply cut and paste this code and we change list 3 like this. So let's run this code. And just as expected, we got 2 columns and we can see the numbers and we can see the corresponding strings in this abstract table. So let's now take a look at stepwise conditional code branching. And here we will take list 2 and we'll set it to an empty list again. And we'll type for item in list 1 if item is larger than 7,000, list 2 append high. If item is less than or equals 7,000, and item is larger than or equals 5,000. List 2, append medium. If item is less than 5,000, list 2, append low. And we can print list 2. So let's run this code. And here we can see that we have the same result. And here we can experiment and change some values. For example, change some values. We can, for example, change this value to 8,000. And we can change this value to 4,000. And we can rerun this code and see what happens. So we run this code again. And here we can see that we have a different outcome. And this is because we have overlapping logic. And this will display the properties of the stepwise conditional code branching versus the ordinary conditional code branching. Because here in the ordinary conditional code branching, we execute the first true statement. And we use the else statement as a catch-all option. And if we don't have an else statement and we don't control the logic, we may have gaps in the logic. And for these gaps, no code will be executed. And the difference with the stepwise conditional code branching is that if you have overlapping logic and code that creates a similar outcome, then you will see the last part of the code executed. So the last true code branch will overwrite earlier true code branches. But in this case, which we have here on the screen, this might not be the case, because here we have a list to append instruction and we don't refer to a particular position in the list. So what happens if we have two code branches which will become true is that, for example, if this code branch is true, we will append medium, and then we will continue the execution to code branch 2. And if that also is true for the same data point, it will also append low to the code. And this is very important to understand with conditional code branching and why many programmers prefer this type of conditional code branching rather than using this type of conditional code branching. Because this type of conditional code branching is very easy to predict, and this can be very hard to trace and find, for example, error or abstract outcomes of the execution. And now we'll take a look at the range length function. we type similar effect, but with range length for loop version. All right, let's type for item in range of the length of list 1 if list 1 item is larger than 7,000, list 2 append pi. And we will also set list 2 to an empty list at the beginning. And we'll continue if list 1 item is less than or equals to 7,000 and list 1 item is larger than or equals 5,000, list 2 append medium. And if list 1 item is less than 5,000, list 2 append low. And we can print list 2. So let's run this code. For low to medium. And as we can see, it executed the same code and we obtained a similar result with a slightly different code law. So what we have done now is that we have used a conditional code branching in the if-elif-if for else with logic operators. And I've used and then less than or equal statements and combined this with a for loop to perform a task which is very common within data science to create classes or to record numbers into classes or categories. And now we'll use the conditional code branching and logic operators to create some basic statistics. So let's type make some simple descriptive statistics using conditional code branching and logic operators. We begin to create a list of unique categories. A list of unique categories. And we will have a new operation counter, which we'll set to 0, a new operation counter variable. And we'll begin to type for item in list 2. If item not in list of unique categories And this is a Pythonic use of the not in logic operator, or you could say Boolean membership logic operator. List do cat append item and print item plus number in category plus string list to count item else loop counter equals loop counter plus 1. And this code will iterate all items in list 2. And the first thing it will do in the if question is to check if the item is not in list of unique categories. And if it is not, it will add the item and it will print the item plus the number in the category plus the count of each of these items in the category. And we will print the number of unique categories are and the length of list of unique categories. And we can print the number of no operation passes or and the no operation counter. And we can print the unique categories are and we can print the list of unique categories. So let's run this code. And here we can see that the low number in the category is 4, the medium number in the category is 2, and the high number in the category is 6. And we can see that the number of unique categories are 3, and the number of no operation passes are 9. And we have a list of the unique categories, and these are low, medium, and high. And we can say that, as you can see, statistics can be edited at a detailed level in Python. And now we'll make a dictionary version of this type of statistics. We type the dictionary version, and this will be slightly different. So we type descriptive statistics equals a empty dictionary, and we type for item in list 2, if item in descriptive statistics descriptive statistics item plus equals 1, else descriptive statistics item equals 1. And we can print a sorted output. We can type for item in sorted descriptive statistics key equals descriptive statistics dot get. Print descriptive statistics item and we can run this code. And here we can see that we had 2 medium, 4 low, and 6 high. And this is a slightly different way to use a dictionary to create the approximately same result. And now we'll try the new match case pattern. So we type try the new match case pattern. And this is a new or at least a recent addition to Python in Python 3.10. So all right, we create a list 4 as an empty list, and we will recode string to numbers. And we will type for string in list 2 match string. And case high We will take list 4 and append 3. And for case medium, we will take list 4 and append 2. And for case low, we will take list 4 and append 1. And for case underscore, we will have list 4 and append 0. And we can type that this is an alternative to the else catch all other alternatives option in the if-else structure. And we will print list 4. So let's run this code. And here we can see that we have 4 low, 2 medium, and 3 corresponds to the high. And now we'll add some logic to the case match pattern logic number to string. We will type for item in list 1 match item, and case item if item is larger than 7,000, list 2 append high. And as usual, we will set list 2 to be equal to an empty list. So we reset list 2 by that instruction. And we continue. So we can type case item if item is less than or equals 7,000 and item is larger than or equal to 5,000. List 2 append medium. And we will have case item if item is less than 5,000. List 2 will append low. And we will use the case underscore and have list2 append other / unknown. And we will print list2. So let's run this code. And here we can see that we used this match case pattern to create an conditional code branching structure, which was equivalent to our first example. And here we can make some tests. So, for example, we can try to add, for example, a string to this list1 and see what happens. And this will generally trigger errors. So we can, for example, see and understand that these match case patterns and also the conditional code branching can be quite limited to, for example, one object type, for example, strings or integers. And this is important to think about. And here we can, for example, test this other unknown catch-all item. So we can change this to less than 1000 because we know we have some 2000 values in the list. So let's run this code. And here we can see that all values which had 2000 was missed by this match case pattern because we changed the logic. And therefore they were assigned other unknown instead of low. So, all right, which version of these examples is the best is a debate and depends on the size of the list, the circumstances, the number of unique classes, and the purpose of the operation. And we must also say that there are plenty of pre-designed statistics functions available in Python and Python's libraries. And the code we showed in this video lecture is pedagogic and very useful when you need to do something that is not covered or easily accessible in pre-designed library functions. So, knowing these operations give you the power to edit and tailor functions at a detailed level. And this may be very useful to know. And now we'll continue to the next video of this video course. And we look forward to see you in the next video.